Now we'll discuss what is energy pricing. So before we learn what is energy pricing, let us discuss what is purchase power parity, PPP. For that, let us understand one example. If we purchase an egg in India, let us say if it costs rupees 3, the same egg, same quality egg, if we purchase it in Japan, say it cost 30 yen. So here purchase power parity for an egg between Japan and India is 30 yen is to rupees 3 or 10 yens per rupees. That means whatever goods we purchase in India in 1 rupee, 10 yens needs to be spent in Japan for the same quality and quantity of goods. Okay, so that means it is just a comparison for the same basket of or rather basket of same goods. Okay, so if we consider the GDP, gross domestic product per country, so based on this example, you will find that it would overestimate the GDP of Japan. Actually, since the egg is costly in terms of their currency, the GDP is overestimated. So what is the use of purchase power parity? That if we use PPP concept, then GDP of all the countries is valued at a uniform price level. Okay, and it will give a clear picture of actual volume of economy. Otherwise, in this example, we have seen that it seems that based on these two values, since it is 30 yen and it is 3 rupees in India, it seems that the economy of the Japan is far better than India, which may not be the case. But if we compare, if we use this purchase power parity concept, then it will make all the currencies on a uniform platform or a uniform level. And then now if after that, if you see the picture, then you will find it will actually reflect the actual volume of economy. So therefore purchase power parity exchange rate equalizes the purchase power of different currencies in their home countries for a given basket of goods. That means it will equalize, PPP will equalize the purchasing power in different currencies for a given basket of goods. Now with this purchase power parity, let us turn towards electricity pricing in India. So if we consider the picture of entire world, the power tariff in India for industrial and commercial sector is highest. So for example, if we see the PPP purchase power parity average tariff in India is 30.8 cents per kWh. That means if I want to purchase power in India, it would cost me 30.8 cents, while the same power I can purchase in 20.6 cents in China, 15.3 cents in Japan, and just 7.7 cents per kWh in US. So how these figures they have calculated? Based on PPP. Then only it becomes comparable. Otherwise, what will happen? We know that the dollar price may be around 70 to 75 rupees nowadays. So $1 cost 75 rupees. So if we do calculation with this exchange rate, it would be difficult to compare the power prices. But if we apply this PPP concept, then you can compare the energy cost in all the countries on the same platform. So you will find in India it is 30.8 cents, but in US it is just 7.7. Next is how electricity pricing in India is. So in India, by and large there are various distribution companies and they have their separate rules for rather tariffs for different category. But by and large, all the customers, they are uh, uh, divided into two main broad categories. One is ST and one is LT. So customer ST means those customers who are catered at 11 kV and above, and LT means it is 440 volts and below. So these are the two broad categories of customer. Now, if we see the energy pricing or electricity pricing for ST customers, it was based on maximum demand, that is a kVA, and energy which is consumed by that customer, that is kWh. So this is what the charging or billing is done on these two parameters, that is the maximum demand which is achieved by that customer during the billing cycle or month. Month is a billing cycle for most of the utilities. So we get the bill once in a month. So it has got two parts. One is maximum demand and one is energy charges. So maximum demand is based on kVA. So how much kVA is registered during that month, you get one component. And second component is whatever energy you consume during that month, that is nothing but kWh. But recently in Maharashtra, we have switched from kWh to kVAh billing. So instead of only dealing with active energy consumption, now we have taken into account apparent energy consumption. This is the change which has been recently implemented from 1st April 2020. Now, what is the difference between these two? Earlier, actually it is not the part of our syllabus, but just you must know it. Earlier we were only charging active energy, and there was a separate calculation for power factor. So we know that if the power factor is below 0.9, then MSEDCL charges a penalty, and if the power factor is above 0.95, then MSEB was giving incentives. Why this was done? Because we know less and less is the power factor, more and more will be the loss in the line, less and less will be the voltage profile. So there are so many disadvantages as far as customer is concerned, as well as far as utility is concerned. So it is disadvantageous for both. So that is why they have made a provision of penalty and incentive, so that all the customers, they will encourage to keep the power factor near to the unity. But in this process, they found that this penalty and incentive, they need to be upgraded continuously, and it was there were disputes also. So what is the solution to that? So they have implemented, instead of charging kWh, that is active energy, and power factor, they have started considering apparent energy. Now, how you reach to apparent energy? We know that power triangle, the one side is active power, second side is reactive power, and the third side is apparent power. And we know what is S, it is P square plus Q square. Now this is in terms of power. Same thing is applicable for energy also. So that same triangle is valid for energy. Only all the three sides should be multiplied by hours. So it will be converted, power triangle is converted into energy triangle. So here you will find, if I consider kVAh bill, that will include, obviously it will include the active power, at the same time it will also include the power factor. So this kVAh billing, by considering just one factor, you will be taking care of your active energy consumption, at the same time power. So if your power factor is low, then you will find that even though your kWh is less, kVAh will be more. So less is the power factor, more will be the kVAh. So you will be billed higher and higher. So automatically all the customers, they will be forced, they will be encouraged to keep higher and higher power factor. So this is the recent change. Okay, but as far as our topic is concerned, you have to just understand The ST building, there are two parts. One is maximum demand and second one is now apparent energy consumption. So this is what ST pricing. Now what about LT pricing? LT pricing is little bit simple. Whatever energy you consume, based on that you will be billed for every month. Okay, so now this is not so simple. In ST and LT also there are different categories. That means whether the customer is industrial, whether the customer is commercial, whether it is a irrigation system, whether it is a railway, port trust, whether it is a agricultural customer. So based on that again tariffs are different. Same is the case of LT also. Now here we have seen the broad categories ST, LT, and further ST and LT are divided into number of categories. Now if we see how the price is fixed, now the price is not fixed by the power company. There are so many ERCs, that is Electricity Regulation Commissions, ERCS. So in Maharashtra it is Maharashtra Electricity Regulatory Commission, MERC, is the apex body which decides the rate of electricity. So MSEDCL alone or any power company, maybe Tata, BEST, they cannot decide the rates they are going to charge from a customer. They have to make a proposal, submit it to MERC office. Then there will be a hearing wherein all the stakeholders of this business will be called. So MERC will be present as a judge, and MSEDCL, Tata, BEST, Adani, whosoever is there in that area, customer representatives, various industries, all they will be called in a meeting, and therein lot of discussions or pleading it goes on. Why MSEDCL and power companies, they propose the rates and the customers, they take different objections. So after this hearing, the prices for energy and are declared to the customers. So right now you will find recently there was a new order. If you go to MSEDCL site and search in a Google that new tariff rate order of MSEDCL, you will get that order of MSEB which is passed by MERC. So now after that, how the rates are determined. So we know that there is a agricultural sector in our country. So for agricultural customer, this government has taken a decision that they should be given unmetered supply. So they don't have meter. Okay, so how they charge? So it is a lump sum basis on HP. So if your pump is of 5 HP, per HP so and so charge will be charged to you. Similarly, if it is a 10 HP, this is the rate. So multiply by that rate to HP, you will get per month bill. But what has happened because of that? Since there is no metering, it has led to inefficient use of the pumps. So nobody is bothered how long the pump is running, because I know I am going to get a fixed bill. So they don't bother. So that is why it has led to inefficient use of pump. This is one thing. And second one is most important. It is over exploitation of water storage. So since the customer, that is agriculture, a farmer, is not bothered whether the pump is running for 5 hours, pump is running for 10 hours, because he doesn't have to pay the bill for the power. So this has led to this one. Now because of that, what has happened? So to recover this cost of agricultural sector, the industrial and commercial sectors, they are billed very heavily. This is very important thing. Now this is for agricultural. Similarly, low economy zone customers are there. So government again does this charity that they are also given lump sum bill for the monthly usage. So because of these things, obviously the cost of electricity is very high and it is increasing day by day. Now, how the power companies, they will recover their revenue? So what they do, they cross subsidize these sectors, and they propose higher and higher rates for industrial and commercial consumers. So that is why you will find there is a disproportionate loading on industrial and commercial sector. And because of that, industries, they find it extremely difficult to manage the show, because their prices of production, obviously this is the energy price, so if it increases, their cost of product increases, and they may not be able to sell their products at low rate. So this is the problem faced by the industrial and commercial customers. Now let us study what is availability based tariff. Now this availability based tariff was implemented in 2002-3. Before that, what was happening? There was no rule or no regulations about the generations and consumptions. That means those who were running the generators, they used to pour the money into the grid, and those who used to draw power, they used to draw power from the grid. So because of that, there was no synchronization rather among the generator units and the load units. So because of that, there was a problem of voltage fluctuation, at the same time frequency fluctuation. And because of this voltage fluctuations, so many problems were created in the grid. Similarly, because of frequency fluctuations, sometimes some of the units, they used to trip on under frequency or over frequency. Because of that, it further led to tripping of another generator. Further, it led to tripping of one more generator from the grid, and this was followed in a cascade manner, and people have witnessed cascade tripping of the grid, and there was a entire collapse of power system. So from that point, power system engineers, they started thinking what can be done. So with this, they came up with the availability based tariff. So it is a tariff structure for work power, and it is aimed at bringing about more responsibility and accountability in power generation and consumption through a scheme of incentives and disincentives, or penalties, you can say. That means in this particular tariff, the person or the company which is generating the power, so they have also some rules and regulations. Similarly, the people who are drawing the power, that means distribution companies, so they have also some rules and regulations. So both of them, they come together, and they plan the generation and the load in such a way that this voltage gets stabilized and frequency gets stabilized. If they don't follow this discipline, obviously they are penalized. So this is what exactly meant by availability based tariff. So in this, actually the annual availability of the generating plant rather than plant load factor is taken into account. That means how much is the load on the plant is not considered. Whenever there is a need, whether that plant is available for the generation or not, this fact is taken into account while doing the calculation. So this is what the introduction of availability based tariff. Now what is the need for ABT? Now typically if we see Indian power system, we know that we are never surplus in power generation. So always in India we have witnessed that the demand is more and generation is less. So this particular thing actually leads to low frequency operation. That means you will study more details in power system 3 about this. You can easily understand by taking a simple example of a generator. When, let us say, a 5 megawatt generator is there, it is supposed to run at 1500 rpm, so that it will generate 50 hertz frequency power. Now if the alternator is supplied with some mechanical power, so it will start generating. Now if the load on the generator increases, what will happen? The moment electrical load increases, the mechanical load is constant. So before the governor understand the situation, if electrical load, it is an instantaneous phenomena, but changing the prime mover input is a mechanical phenomena. So obviously it has got more time constant. So it will take a little bit of time to understand that electrical load has increased, but electrical load will increase in real time. So the moment electrical load increases, what will happen? That generator has got less mechanical input. So obviously the energy which is stored in the rotor will be temporarily utilized to create more power, electrical power, so that delta P will be taken from the rotor. So obviously there will be a fall in the speed of the rotor. So when there is a fall in the speed of the rotor, we know the frequency of alternator gets reduced. So this is low frequency operation. Now this fall in the speed is immediately sensed by the governor. Now earlier in old systems, those flyball mechanism, mechanical governors were there. So they were sluggish in operation. So they used to sense after much of time, and then they used to make the changes. So during that process, sometimes system used to become unbalanced. But right now that is not the case. All those mechanical governors, they are replaced by electronic fast acting governors. So they are too fast, and they change this, they sense this system that there is a fall in speed, and immediately they open the or admit more input, mechanical input to the rotor, thereby again restoring the frequency to the normal 50 Hz frequency, or keeping the speed of the alternator to 1500 RPM or whatever is the intended speed. So they will maintain that speed so as to we get a stabilized frequency. So but in Indian scenario, we know that the amount of power which is generated and the amount of load which is there on the system, it is always disproportionate. So load is more and generation is less. So that is why we always face low frequency operation. Now second thing is, when we consider developing countries like India, so always we don't have our economy is not so strong. So always there is a financial constraint. So we cannot construct our more power plants so easily as compared to the developed countries. So this is one fact. And second is we have huge population. So this is second point. And the third point is these resources, they are unequally distributed in the country. So they are not physically located evenly in our physical area. So that is what the problem is. So that means the power generating plants, they are not distributed, they are lumped at particular point in the country. So if they were distributed evenly across the entire nation, then this problem would have not come. But it is not the case. They are basically they are confined to some particular physical area. So what is the problem? So because of these problems, we find that those transmission lines and distribution network, they are not adequate. So because of that, what happens? The loading on the line, it increases. Some of the lines get overloaded, and because of that we suffer from low voltage profile. Now there are so many other problems that we'll discuss some at some other point of time, but because of that the voltage profile gets reduced. So this is what the problem. So if we want to solve these two problems, that is frequency variations, which leads to cascade tripping, and second is low voltage profile. Because of that, not many problems are faced in power system. So for that there is a need of ABT. I hope I am clear. Now let us discuss what are the components of this availability based tariff. Now, as we have discussed earlier, that it is the exchange between the generators and the load consuming companies. So now the payments which are done by the load distributing power distributing companies like MSEDCL, it has got three basic component, A, B and C. So first component is called as a capacity component. What do we understand by this is the companies, they are normally they have got generation companies, they have got some fixed charges. So they might have taken the loan, so that company needs to repay the loan. Then return on equity, they might have generated funds from the share market, so they need to give incentives to their stakeholders. Then the plant, its depreciation, that means as the plant becomes older and older, its value will go on reducing, so that generating company has to take this depreciation into account and recover some amount from the customers. Then next point is operation and maintenance charges, so that generating company has to do some maintenance, so that maintenance cost has to be recovered from the customer. Then they have to do insurance against accidents or employees, those who are working for safety of those working personnel. They have to do some insurance so they have to get the premium of that insurance recovered from the customers. And obviously there are various taxes which are imposed onto the generating plant, so those taxes are to be recovered. So this is what we can say a fixed charge. Whether the plant is working or not, every generating company has to do all these expenses. So this availability based tariff, there will be one component which will be contributing towards this fixed charges. Okay, so that is called as capacity. That means actually that capacity, it is linked to the availability. Okay, so that means if the plant is available, we'll discuss this point in the next slide. So this is one thing. So capacity means actually the fixed charges, amount is recovered from the customer so as to cater these expenses. So this is what capacity. Next is energy charges. We know that every plant, may it be nuclear, may it be thermal, so they use some fuel, this enriched uranium or coal or oil. So these are the fuels. So the running expenses are recovered through this energy charge. So this is what the energy charge means. We are actually recovering the running charges of our plant, generating plant. So this is the second component. And third component, and which is very important, is called as unscheduled interchange. Now what is this unscheduled interchange? So basically the generating company and the power distributing company, they declare that generating company declare that I am going to produce say X megawatt tomorrow. Okay, during this period to this period I will be generating this much of the power. Similarly, those distribution companies, they will also declare that I will be requiring this and this power. So both of them, they meet on one particular conclusion, that I will be generating this much amount and I will be consuming this much of amount. So this is what the we can say schedule between the two parties. Okay, so this is called as scheduled power. Now when it comes to actually next day, when it comes to the implementation, we know that neither the generator nor the load distribution company, they don't have any guarantee that what will be the load. It is their prediction. So sometimes we find that the company which has said I will generate X megawatt, they may generate X minus 1, or they may generate x plus 1. So they might generate some additional power, or they might not generate a required power. So this is one scenario. On the other hand, the distribution company, they have agreed to purchase x power, but they may require x plus 1 power, or they may require x minus 1 power. So in this case, now it's very interesting. So this is called as unscheduled interchange. So it was not planned. It has happened accidentally. Now, based on that, how it happens and what is the frequency at that time when this unscheduled interchange was happened, based on that, there is a tariff. It is called as unscheduled interchange, UI. Okay. So these are the three basic components. So first two components, they are very easy to understand. Some money, because I need some annual maintenance, interest, salaries and office overheads and all those things. So I need to do this maintenance or do these expenses over the year continuously, whether my plant is working or not. So this is called as fixed charges. If I run the plant, obviously I need to purchase fuel. So this is called as running charges. This one. So I have to recover this amount from my customers. That is for sure. So these two components are fixed. But the third one is, this is the basic, actually behind basic UI is the key in this tariff. So that means now you will understand that if the rules are written in such a way that if you generate more than the demand, you are penalized. And if you consume more than the requirement, then again you are penalized. So everybody is compelled to stay within the limit. Whatever I have agreed, I have to maintain that band. And if you surpass that band, obviously you have to pay either penalty or you will get some incentive. So this is what the basic idea behind the, or rather components of availability based tariff. Exactly we'll understand in the next slide. Okay, now just revise the previous term. What is capacity charge? So it is linked to the availability of the plant. It is the reimbursement of fixed charges for loan, return of equity, depreciation of the plant, operation and maintenance charge, insurance, taxes, etc. What is the energy charge? It is taken to reimburse the fuel cost. So here we have to understand that the energy charges are calculated on the scheduled generation, not in the actual. Let us say if I have scheduled 500 megawatt and so much of fuel is going to be used in that one, so I will recover that amount from the concerned party. No longer whether I generate 400 or 600, that is not a matter. That doesn't matter. I will recover the fuel cost which is required for scheduled generator, not the actual one. So this is what energy charge. And last one, as I discussed, unscheduled interchange charges. It is the payment for deviation from the schedule depending upon the frequency at that time. Okay, so here frequency is very important. Now let us consider one example. Let us say I have a generator, 600 megawatt generator, but I have declared that tomorrow I will be delivering, I am ready to deliver 500 megawatt for next 24 hours. This is how I am a generator owner. I have declared this. Okay, now let us say I have declared 500 and if I generate 600 megawatt, now what will happen? Now that payment of 100 megawatt will depend on what is the frequency. That means if there is a surplus power in the grid, okay, there is a surplus power, already the frequency is very high, surplus power, and I have generated more power. So that means if frequency is high, so you will not get a higher rate, you will get very lower, because already the grid has got excess power. Why you are pouring and making the problem difficult? So you are not supposed to pour any power in the grid, because grid is already has excess power. So you are not supposed to pour any power, so you will not get a higher rate. But if the frequency is low, that means already the grid frequency is reducing. That means demand is more and power being poured in the grid is less. So because of frequency has reduced, at that time if you pour excess power, you are welcome. You are pouring power when the grid needs it. So it is low frequency zone, means grid is actually demanding. I have to stabilize frequency to 50 Hertz, so without which I cannot survive. So if the one who helps the friend, when he is in need, he will be obviously benefited. So you get additional cost for that 100. So you get very attractive rate. Maybe let us say if the rate of this one scheduled rate is 2 rupees. So if the high frequency is there, you may get 10 paisa for that 100 megawatt. But if the frequency is, let us say 49, you may get 5 rupees for that, because grid needs it. Otherwise there will be a collapse, or one has to go for load shedding. So that is why. So here you will find that by and large we can make 4 cases for unscheduled interchange. If the beneficiary, that means distribution company, overdraws the power than what is committed, so frequency will go down. If beneficiary underdraws the power, I have committed 500 but I have not lifted, my load is only 200 megawatt, so the generator person is pouring 300 megawatt, what to do? So at that time frequency will go up. Then the generator generates more than the schedule. I have committed for 500 but still my generator has generated 600. What to do? Frequency will go up. Generator generates less than frequency, less than the schedule. So again the frequency will go down. If I have committed 500, I am generating 200. So obviously 300, there will be a deficit in the grid of 300 megawatt, and then somebody has to pour that, otherwise grid will collapse. So that is why the one who pours that energy will get benefited, but definitely I will get penalized because I have not followed that schedule. So I hope you might have understood how this business is. That means there is a restriction for the generator, there is a restriction for user also. So the user has to draw that power, generator has to. So this is how, by making this penalty and incentive business, we have tried to stabilize the frequency, and obviously because of that, because of this discipline, automatically the voltage profile also gets improved. So this is what it is being done. Now let us discuss the exact chart. How is that penalty? And then you will exactly understand this scene. Okay, so let us see the next slide wherein that chart is given. Now this is a dual sloped UI rate curve. Now you will find on the x-axis there is a frequency, on y-axis it is the UI rate. Okay, so now see, this is what on this is the amount written, what is the rate is written per kWh, and here the frequency is written. Now let us consider if the grid has surplus power. So obviously you will find where the grid will operate. Grid will operate in the zone of 50 plus. Okay, so 50, maybe 50.1, 50.2. Now you will find when the frequency is high, you see what is the rate. So you will find it is very less, even not even 50 paisa. Okay, so the rate is quite low. But at the same time, if you see the initial zone, when the frequency is 49.5, you will find the rate goes to almost 8.8 rupee 80 paisa, or maybe 9 rupees you can say. So for per unit you get 9 rupees. So that means when the grid is having a surplus power, that is frequency is high, if you generate, if you pour power, this is of course for only unscheduled power. For scheduled power the rate is already fixed, but unscheduled interchange will be dealt like this. So that means you will not be dead when there is a excess power. Immediately you will stop your generator pouring more power. Similarly for the customer, if the frequency is very high, so obviously you will try to load your encourage your customers so as to take the more power. Or if the frequency is less and your load is increasing above the scheduled power, definitely no power company will allow. They will better go for load shedding, because they know if I continue to draw the power like this from the grid, obviously I will have to purchase the power at much higher cost, and which will not be definitely recovered from the customer, because they will be giving power at a fixed cost. We never bother when we are drawing the power, isn't it? In the bill you don't mind when I am drawing that power in the morning or in the evening. You keep on pumping the power and you pay at a fixed rate. But this power distribution company has to pay the generating company at when they have drawn the power, whether it was surplus power in the grid or whether there was a deficit in the grid. So depending upon that, if there is a power shortage, if you draw more power, you will be penalized. If there is a higher power in the grid, if you leave the power, then you are most welcome. So like that, this grid discipline is maintained, and because of this, there is a grid discipline. So after 2003, this grid has fairly stabilized as far as frequency and voltage fluctuations are concerned. Now the curve, what you see, it is a dual rate curve. Initially when it started, this tariff, people also were not knowing. The one who proposed this scheme, he initially gave the only one slope, but later on they found that if we make multiple, so you will find as the frequency becomes less and less, let us say 49 point maybe 5, the slope of the line changes. It becomes more steep as you reduce the frequency. That means now beyond this point, if you try to load the grid, you will be penalized heavily like that. Okay, so this is what the availability based tariff. So I hope you must have understood that as the name suggests, when there is a power is available, if you use, there is no problem. If the power is shortage and you are demanding, obviously you have to pay a higher rate. So this is what all business of ABT.